All right, since I went ahead and gave you this example, let's solve it both ways using the power and the product and the quotient rule. So we have one example where we sort of worked with both. So let's deal first with the product rule because I think this is a simpler problem to do. And technically at this point, we haven't written down those derivatives of the other trig functions. So let's play first with this one. All right, so let's think of this again, same way we did last time. We have a f of x, right? If we want to use the work in the actual module, that's sort of g of x and f of x, multiplied with a different function, g of x. No way to combine these up in any fun or useful way, so we're going to go ahead and use the product rule. So our text, our Canvas shell, says we're going to take the first term, the first factor, our first function, I'm going to take its derivative, multiply that by our second function, as is, add it to the first, no need for a derivative, and then times the derivative of our second function. Cute. So let's go ahead and evaluate those two derivatives. X cubed, just a power rule. Cosine of x is one of our trig functions that we got in this section, which is negative sine of x. And then we'll bring down the other pieces that were just sort of set. Cosine of x, the plus, our x cubed. And here's where we need to be careful. We're having a lot of trouble with parentheses. Make sure, like as this is written, it looks like we're subtracting that sine of x as opposed to multiplying by a negative sine of x. So putting parentheses around it makes it clear it's multiplication. Even better would be to go ahead and just move that negative as a coefficient out in front. There's no reason to have it floating in the back there where it could be like mistaken for subtraction. So you could get there. If you want to, you could even go ahead and factor out an x squared, which might be useful if you were doing a problem that had to do something else with this. But I never wrote, and I should have written, oops, these are all my derivative, right? So there we found our f prime of x. So let's go ahead and use the quotient rule. I should have a break here to go ahead and do this where I find, we found in class this year, for fall of 2022, we found in class the derivatives of our reciprocal and our quotient identities, the tangent and secant. We found those just using the quotient rule with 1 over cosine. But for now, I'm going to assume we know the derivative of secant is secant tangent. So we're going to go ahead and do the quotient rule to solve this same question. So let's bring it back. We have f of x is equal to x cubed over secant of x. And we can see why it would be really nice to just recognize right away I could use the product rule if I rewrote it. Because now we got to do our whole low d high minus high d low over low low. So let's do it. We have low, and I'll just keep my colors the same. Low d high minus high d low all over low low. And I'll write it this way, even though I know I can shove the square in the kind of between the secant and the x. So let's go ahead and take our derivatives. We only have 2 to deal with here, just like in the product rule. These are the things we got to take derivatives of. So we'll go ahead. We have a 3x squared, just like in our our product rule. And we have a secant x tan x. There. So already uglier because I needed to know the derivative of secant, which a lot of students don't have memorized. This is all over secant squared. I'm going to leave it the other way actually, because I think it'll be more obvious when I do my next step. So remember, previously the answer was much cleaner. We ended up with this. So how do we verify that they are the same? This is always the challenge of a calculus class. Like the back of the textbook has the answer, but yours doesn't look like it. So first we got to recognize, oh, it does appear I can have a secant in both of my terms in the numerator. So let's go ahead and factor out a secant of x. Then we'll have a 3x squared minus x cubed tan of x. This is all over secant of x squared. So I can go ahead and realize, okay, I can pull out that common factor of secant from the top and bottom. Really shouldn't cross out the whole thing. I should just cross out the square. Okay, so now I am here. I've got 3x squared minus x cubed tangent of x all over secant of x. And now you're seeing why you suffered so much if you took Math 104 with those proofs of the identities, because there's so much we have to do to make this look like our previous one. So we go, okay, well, let me just rewrite this by splitting up that fraction. This is the same thing as this. Okay. Well, I'm feeling better already. I recognize that this first one, this is just 3x squared cosine of x. I needed that over here. 3x squared cosine of x. I'm good. The other one, I got the x cubed, but I don't have the sine of x. But then I remember, ooh, let me try something. Let me try rewriting tangent as sine x over cosine x. Let me try rewriting secant as 1 over cosine x. And then I could either multiply the numerator and denominator by cosine x, right, cosine x over cosine x. I could do my fraction division, multiplying by that reciprocal, and then the cosines cancel. But either way, however I decide to get there, I should be able to prove to myself that tangent divided by secant is sine of x. So there we go. We got to the same answer, but a heck of a lot more work, and your answer is not probably going to look like the back of the book if you just, like a bull, put your head down and start working on a problem because you see a quotient when you could be more clever about how you approach it.